Now, to understand how some of the interaction works between our switches and our routers, we're going to talk about broadcast domains and collision domains. We got to take a little quick step back in history and define a couple of terms for you. Now, back in the day when I was first working with networks, I mentioned that I worked with a 10-base-2 network where we had this actual coaxial cable running through the length of a building floor, and we would tap into that. And it looked basically like this. This was called a bus topology, and it was an Ethernet bus. And it used something called good term for your notes, CSMA/CD. CSMA/CD. Carrier sense multiple access with collision detection. And what that means is the multiple access means that we can have multiple devices accessing the same medium, the same wire. And carrier sense means before we transmit, we're going to listen. We're going to hold our ear up to the train track like they used to do in the old movies. We're going to see if there is anybody talking right now on the network. But because there's a requirement, we can only have one packet on this entire bus at any one time. So it's not terribly scalable. But we can only have one person talking at any one time. So before we transmit, we listen. Crickets, I don't hear anything. I think it's safe to send. So then we'll send our data out, and there's bad news. The same time we were listening, this other guy was listening. We heard the same period of silence. The two bottom computers on screen, they both simultaneously concluded, I think the coast is clear, let's go ahead and send. So they transmit, kablooey. They had what is called a collision. A collision is when two transmissions collide. And we'll be using that term collision quite a bit. What do they do, by the way? How do they get away from this? Well, they still need to send their data. They know it's been corrupted. It collided. So what they'll do is they'll both just kind of set a random timer, a random back-off timer. The guy on the left might say, I'm going to wait for 10 milliseconds. And after 10 milliseconds, I'm going to send my data. Hopefully, the other person picked a different random number. The other person picked 20 milliseconds. So after 20 milliseconds, they'll send their data, and hopefully there won't be that collision. They'll be able to pass smoothly past each other. Now, what we just saw was the Ethernet bus that used CSMA/CD carrier sense. We're listening first. Multiple access. Everybody connects to the same wire. Collision detection. We can see if a collision occurred because there's going to be a spike in voltage when that occurs. That's kind of what's going on with the old Ethernet hubs. But a shared media hub is acting logically like that old Ethernet bus. There's only one person that can talk at any one time. Collisions can certainly happen if two people listen to the same period of silence. They're just wired up differently. Instead of having this cable just run throughout the building floor, everybody comes back to a wiring closet. They come back to a hub. So physically, this is called a star topology, where we radiate out from the middle of the star. But logically, it's still a bus topology. It's still working like the old Ethernet bus did. And yeah, shared media hubs, they're just not scalable these days. But the great news is when everybody wired their connections back to the wiring closet for those hubs, we could just swap out the hub with a switch. Now, the switch doesn't treat everybody that's connected to it as being on one big network segment. The switch treats everybody as an individual. The switch treats them as their own point-to-point connections. So we're not going to have a collision happen. We should not have a collision ever happening. So we don't need to do CSMA/CD. In fact, another drawback to the old hub way, we can only run in half duplex. In other words, I could only be sending or receiving at any one time. I could not do both at the same time. With switches, we can. We can run in full duplex because there's no chance of collision.